Thanks for taking the time to watch this video. Just a note that if you're ever interested in private tutoring, I do offer that service online via Google Meet or Zoom. You can contact me at the email address right here for more information. Moving on to the solution here, you might want to pause the video, reread the problem before listening on. But basically, we have somebody trying to catch a falling dollar bill, and their reaction time is only 0.2 seconds. So in order for us to understand why this would be a very challenging, actually impossible situation with that reaction time, we can come down and look at this picture. Now, I had to look up the dimensions of a $1 bill. It wasn't actually stated in the problem, but it turns out that the length of the bill is 15.6 centimeters approximately, which means that half of its length is 7.8 centimeters. We have drawn David's mangled hand right here, and what's going to happen is Emily is going to drop the $1 bill, and as it falls, such as this is my attempt at animation, David is going to try to grasp it. Now notice that if the bill falls more than that 7.8 centimeters, let's put it back to where it was. Oh boy. If the bill falls more than 7.8 centimeters, he's not going to be able to grasp it. So for example, if it fell 8 centimeters, it would fall beyond the reach of his hand and would continue falling. So he only has a distance of 7.8 centimeters to grasp that bill. Again, if it falls more than that, he won't be able to catch it. So the question is, how far does the bill fall? What is its vertical displacement in that 0.2 seconds? Now that's a relatively straightforward calculation because we know that the vertical displacement would equal the initial velocity of the bill multiplied by the reaction time plus 1/2 times the acceleration of the bill multiplied by the reaction time squared. Now, the bill is being dropped, so the initial velocity would be 0. And if you look at this term right here, 0 times time, of course, would be 0. So that term drops out of the equation. We then have 1/2 times the acceleration due to gravity. Now, gravity accelerates the bill, like it accelerates everything close to the surface of Earth, at about 9.8 meters per second squared. And then the reaction time of David was stated to be 0.2 seconds, and do not forget to square that value, please. So let's pick up our calculators and see how far the bill falls in that 0.2 seconds. And it turns out to be 0.196 meters. Now, let's convert that into centimeters so that we can compare it to the distance stated earlier. Of course, we know 1 meter is 100 centimeters. So if we multiply by that conversion factor, we see that the vertical displacement of the bill is going to be 19.6 centimeters. Now remember, we said that if the bill falls more than 7.8 centimeters, he won't be able to catch it. Well, 19.6 is certainly greater than that 7.8 centimeters, and that means that David will not be able to catch the bill. His reaction time is just too long. So David will not, be able to catch the bill. It would be an interesting exercise. We were not asked to do this, but we would need to solve for his reaction time, assuming that the distance would be that 7.8 centimeters. Now, as an addendum to this video, we can do that. 7.8 centimeters would be 0.078 meters. That would be the vertical displacement. We would set that equal to 1/2 times the 9.8 meters per second squared times time squared. And if you solve that out, which I'm going to do real quickly here on my device, if you solve that out, you will see that the reaction time needed is about 0.13 seconds. So if David could react within 0.13 seconds, then he would be able to barely catch that bill. Unfortunately, his reaction time is too slow, and as stated, he will not be able to catch the bill.